Good morning, all. In today's class, we'll discuss cyber physical systems. Cyber physical system is nothing but it is integrations of computation, network, and physical process. So it consists of computational components, physical components, and communication network. Okay, and it is widely used in various domains such as healthcare, manufacturing sector, automotive sector, aerospace sector, and smart grids. Now, if you look at the components for this CPS part, what we have embedded system, software algorithm, control systems, and data processing unit. That is under computational components. Then under physical components, we have sensors. Basically, it is used to collect the real world data. Then we have actuators, which is used to interact with the actual working environment. Then mechanical and electronic systems are there. Then communication networks. So communication networks are again three types. Either you can use wireless and wired networks, or we can use IoT connectivity, or we can use a cloud computing and edge computing integration. So this will come under this part of communication network. So if you look at the implementation, suppose if you want to develop this CPS, to develop any CPS systems, uh, there are some basic criteria, you can say characteristics, which we need to uh, take into account whenever we are developing that CPS part. First is real-time processing. So CPS must process and respond to data in real time. Then second is interconnectivity. So various components are communicated through networks. Then we have autonomous control, like some CPS applications are having like self-driving cars or that operate autonomously. Like we have discussed the example of Tesla in IoT systems where that IoT algorithm is taking data of obstacle nearby that particular car. So it will provide that data, and that algorithm is designed in a such a way that based on this data, the system will operate. Okay. Then third, next is a feedback mechanism. So feedback mechanism is nothing but it is a combination of sensors which is used to collect the data. Then that based upon the response of that particular system, we can control the intermediate moment or intermediate uh, operations of that particular device. Then we have security and safety. So CPS must be secure and resilient against the cyber threats. Those are the characteristics of CPS. Then next is we have some examples of cyber physical system. Now we take example of industrial automation. So mostly in smart factories, we have automated robots. Okay. So and control systems again that is a example of CPS. Then for healthcare systems, we can use CPS for remote patient monitoring, robotic surgery, autonomous vehicle like safe driving car which is using AI and IoT. We have smart grids, that is intelligent electricity distribution and consumption management. So based on the requirement, that particular electricity will be delivered to that particular consumer based on the requirement. That facility is also available. We have smart meters. Then next is smart cities. So basically for traffic management, for environmental monitoring and public safety systems, you can implement this CPS. Then next is manufacturing. Like suppose if you go with the uh, implementation of CPS. So in manufacturing industry 4.0 smart production lines, CPS is implemented. Then for healthcare industry like wearable health monitoring systems. For transportation purpose, intelligent transportation system is available. Then again, energy and defense, we have discussed this part of drones, autonomous drones, and security communication system. Now, what are the different challenges are there? That is the important part. So if you go with the security and privacy, so protecting that system against the cyber threats, that is the biggest challenge. Then real-time processing. Now, multiple systems are connected to each other, so we need to ensure the fast and accurate response. Then interoperability. So integrating different hardware and software systems. Again, that one more again challenge. Then scalability. Now, whenever you are expanding that system without performance degradation, you have to consider this overall integrations of that system without affecting the performance. Then cyber physical system is nothing but it is the backbone of modern smart technology and automations we are saying. So it can bridge the gap between digital and physical world for improving the efficiency, safety, and productivity. Now, just I will show you some examples how we can integrate the system. Now, basically, this cyber physical system, cyber world is coming whenever we are talking about the components related to uh, computational part. Like suppose we have communication cloud, we have sensors, we have storage systems. Okay, and then this physical parts is nothing but we have actuators and data related to that particular part, like computing data. We are computing that data based on the available informations taken by the sensors. So if you look at the overall flow, so what we have basically sensors, we have computing that part, we have communication devices, we have actuators which are working under the environment, and then we are storing the data. So this based on this particular overall analysis, we can define the overall behavior of system. So we have the data, so that sensors will create the actual environmental data of that particular system. Then the data will get stored at storage, that is on cloud. Then it will go, it can be analyzed, okay? And based on that analyze, again, we have some feedback mechanism for communication purpose. And finally, we can compute the actual performance of that particular system with the CPS. Okay. Now look at the integrations like architecture. What is the architecture of this cyber physical system? So what we have now, we can configure the we can configure these systems. We can copy. We have communications. We have cyber part, convergence part, and connections parts. Now what we have, just look at the overall view. Suppose if you want to control the any operations. So we have some required action supervisory control purpose. Suppose if we take example of software operation. Okay. Now we have some targeted particular part at the end of that operation. So that suppose if you are manufacturing 100 jobs, so what is the target? And based on the target, we can analyze the overall behavior of that system. Now to get that target of 100 machines, what we have some integrations of different components. Like I can use some robotic manufacturing process, some CNC part. I can analyze the uh, time required for each and every functions. Okay, that I can calculate. That means we can analyze that particular part. Then we can convert. So based on the requirements of systems, whenever we are setting any new devices or whenever we are analyzing any performance of new devices, we have to analyze the required parts or required components. And suppose you just look at the example, what we have, we are taking one example where we are targeting, suppose I have to manufacture 100 gears on a single machine. Now, to integrate that particular CNC or VMC or gear robbing machines, what we have, I can select the appropriate particular systems which can enhance the overall production of that particular gears. Then based on the requirement, I can check the overall speed, overall its manufacturing performance based on the this interconnections. Like I can use the sensors to for data collection purpose, and then we can say that suppose say for single shift the 10 machines are performing 100 gears out of 10 which are inappropriate or perfectly producing that particular gears. So based on the accuracy, we can define this part. So this is the overall architecture. So in this part, what we are doing, we are taking the actions which is actually required for better accuracy. And then based on this, our requirement, we are analyzing this performance by considering this condition monitoring. So for each and every purpose, whenever we are talking about accuracy of gear or accuracy of particular machines, okay, we have to set some parameters, and based on that performance, if your machine is performing well, then that system is useful. Now, next is look at the system, how that system is taking the data or how that system is collecting the information. That is important. So what we have sensors. Like sensors is used to collect the data. Okay, now that data collected by that sensors is stored at communication network. Like we have some cloud storage, we have some Google storage, we have AWS storage. Azure, we have discussed this part in big data part. Now after storing that data, we have to analyze that particular data by scheme analysis or any Apache Hadoop analysis. That part we can do. And once that data will get analyzed, okay. Now, based on the requirements, whether this, suppose let's take this example of physical element of 3 machines. Okay. Whenever we are comparing that data of actual systems, if you want, if you are getting that data, your only 2 machines are performing well as per the requirement, and 1 machine is not performing well, or it is not producing that gears as per our accuracy or precision, we can immediately stop that particular system. That facility is there. So whenever we are analyzing any performance of any system, we have this feedback mechanism. We can check the actual physical condition. We can analyze that particular part on with the help of data analytics tools, and then that output will get reflected to user interface or that particular dashboard. Okay, and this is the overall flow you can use to analyze any performance of system with the help of CPS. Okay, so this is the overall system. How we have discussed this part, integrations of CPS. What is CPS? What are the different applications of CPS, and how this CPS will be useful to monitor the any systems. Okay, to analyze the performance of any systems that we have got. To stop here in next class, we'll discuss the benefits of this CPS. Thank you.